I'm creating this video for us to walk through the two monosaccharides, glucose and fructose. Walking through this with this video in lieu of class because of election day. So let's get out your notes and walk through these facts about glucose and fructose with me. So glucose and fructose, we learned before, both have the same molecular formula. They're both C6H12O6. But we're going to want to see what's different about each one. So first of all, facts about glucose. Glucose occurs in most fruits, but it's abundant in grapes, figs, and dates. These are three fruits that we easily dry and eat as dry fruits because they have so much sugar in them that it preserves them pretty nicely. So let's see. What are some other ways that glucose is referred to? If you hear about a sugar called dextrose, and that's just way too fat. Let me make that a little smaller. Dextrose is glucose. Another one, you might hear it referred to as blood sugar. And this is because this is the form of sugar that our bodies can use. So when it's carrying it through our bodies in a useful form, it's in the form of glucose. And because grapes are so high in sugar, this kind of sugar sometimes is referred to as grape sugar. Now, I will admit to you that I have not ever heard it referred to as grape sugar, but I have certainly heard it referred to as blood sugar and most frequently as dextrose. So whenever you eat any other carbohydrate, and this means from simple to complex, before your body can use it, it has to be converted to glucose. So that is what's going to happen in your body. Now, the many hydroxyl groups. What is a hydroxyl group? OH group. Okay, this is called a excuse me. Had a lot of coughing there. Okay, this is called a hydroxyl group. And our sugars have many hydroxyl groups. Because of all the many that are on it, it makes it very soluble. In water. So pause the video and just look back in your slides at the structure of glucose that I gave you, and you'll see all the OH groups around the ring for glucose. So what does our body use glucose for? It uses it to give our cells energy, okay? So glucose is used by our body to get energy for our cells. Now, if you have strenuous exercise going on where you're not getting in quite enough oxygen, when your body uses glucose, it converts it to lactic acid. If you have plenty of oxygen, on the other hand, it gets converted to carbon dioxide and water. When it produces the lactic acid, this is what makes your muscles burn. If you've ever done strenuous exercises and you get a burn in your muscles, that's a buildup of lactic acid in those muscles from there just not quite being enough oxygen in your bloodstream to convert it to what it would like to convert it to, which is carbon dioxide and water. So if it's not strenuous exercise, if you've got plenty of oxygen in there, then this is what's happening. This reaction is exactly the same reaction as a combustion of this substance if it were to happen out in the atmosphere. So C6H12 O6. Combustion means reaction with oxygen. We saw this reaction when we were talking about oxidation reactions at the end of our Unit 1. It's going to form carbon dioxide, it's going to form water, and we should balance it. There's 6 carbons and I need 6 carbons. There's 12 hydrogens on the left. I need 6 hydrogens on the right. That gives me 6 times 2, which is 12 oxygens there, plus 6 more, that's 18. So if I put, that is not right, 18, there's already 6 here, so I need 12 more. So if I put a 6 right here, it's balanced. So if this reaction takes place out in the real world, it produces fire. But if it takes place in our body, it just gives us the energy we need. All right, so it's exactly the same as combustion. So how does it happen in our body? Well, inside our body, the reaction is carried out with enzymes. So the body uses enzymes to allow the reaction to take place not at high temperatures like it would outside the body, but at 37 degrees Celsius. That is body temperature. Now, sometimes we consume too much carbohydrates, and our body is still busily converting our carbohydrates that we consume to glucose, but we have too much. So if it isn't used, it has to be stored. It doesn't just go away, it gets stored in our bodies. And there's 2 primary ways that it gets stored. It gets stored as glycogen. Glycogen storage is short term. And it's stored in the form of a polysaccharide. It's a chain, okay? It's a chain. This is representing a glucose molecule attached to a glucose molecule attached to a glucose molecule attached to a glucose molecule. So what we're seeing here is a polymer, okay? We call it a polysaccharide. Our body can store it as glycogen, and we'll look at this a lot more later when we are continuing in on this section. The second way that it gets stored is as a triglyceride. Triglycerides are for long-term storage. And it is what we would call fat, okay? This is your triglyceride here for long-term storage. And again, we will examine this more later when we get into our section on fats. So that's what I want to tell you about glucose at this time. Now let's look at fructose. Fructose is going to be, again, the same formula, C6H12O6, but it has a different structure. It's a 5-membered ring instead of a 6-membered ring. Another name for fructose is, I'll say it this way, also called fruit sugar, because it's contained in a lot of fruits. Now, glucose was as well, but glucose was more concentrated in the figs, the grapes, and the dates. Most of your fruits will have the fructose in it. It is the sweetest of the naturally occurring monosaccharides. It's about 2 times, that stands for 2 times as sweet. Maybe we ought to say 2 times sweeter than glucose. It's more sweet than our table sugar, which we'll learn about later. and therefore it's less fattening. And it's only less fattening because you would use less of it to get it to be just as sweet. Now, honey is a mixture of both the glucose that we've already examined and fructose. So we have both of those. But your most common source of fructose is high fructose corn syrup. Now, your body is going to have to convert that fructose to glucose before it can use it. So you might be using less calories, consuming less calories, but your body can't use it in the form of that five-membered ring that we saw glucose and fructose was. It's got some chemical reactions it will have to do to convert it over from fructose over to glucose. So that's all I wanted to tell you for now about those two simple sugars.